y'all. Today, we are gonna do simplifying radical expression. Sorry I can't be there today, but we will get through it together. Okay, so we are on pages 3 in our notes. So Sage purchased a caravan that has a square window and the side lengths of X. If the window has an area of 144 square inches, write an expression to represent the side length of the window and then simplify the expression. Okay, so I'm going to kind of draw this picture. So we have a window, okay, and the side lengths we don't know are X. It's a square window, which means that they would have to be like the same side on each side. It also says that the area is 144 square inches. So area is the inside. So we know that the area or the inside is 144. Okay, so to figure out the side length, we would figure out, okay, what number times itself would equal 144? And the answer to that would be 12, because 12 times 12 does equal 144. All right, so another way to do this without just like using our common sense of perfect squares is by taking square roots. So square roots are examples of radical expressions and are often used to help us solve quadratics. So this is going to help us for the rest of this unit. So a square root usually doesn't have anything right there. So an expression will have a radical sign. Okay, and the radical sign would be right here. Okay, if no root index is shown, such as like the symbol with 49, it is assumed to be the index of a 2 or a square root. So this is called our index, and that tells us what we're taking the root of, whether it be a cube root, a square root, and then when you get older, you'll do more difficult roots. And then the thing under here we call our radicand. So what are we taking the root of? Okay, when simplifying a square root, list the principal or just positive square roots right now. Okay. So to simplify radical expressions, like we know that the square root of 144 is 12, because 12 times 12 is 144. But sometimes we don't have square roots, like the square root of 145. You get this decimal that goes on forever and ever and ever. So what we like to do is we like to simplify them. So we like to simplify them by assuming that a and b are numbers. So if we have a number times another number and we're taking the root of it, we could simplify it by taking the square root of a and multiplying it by the square root of b. Because this is still multiplication, we're just kind of separating it out to help us see it. So using the fact that we know that the square root of 100, so the square root of 100 is 10, because 10 times 10 is 100, what we can do is we can simplify it a different way using perfect squares. So we agree that 25 times 4 is 100, okay? And so what we can do is we can kind of break it up into pieces, the square root of 25 times the square root of 4. Well, we know that the square root of 25 is 5, because 5 times 5 is 25. And we also know the square root of 4 is 2. And we know that 5 times 2 is 10. So this is a different way of doing square roots using perfect squares. Okay, so what this just shows us is we can break it up into perfect squares that we feel more comfortable with. Okay, a square root radical expression is simplified when the radicand, or the number inside the radical sign, has no perfect square factors. Okay, other than 1. So the square root of 15 is in simplest form because no other factors of 15 are perfect squares. Okay, the square root of 12 is not in simplest form because one of its factors, 4, is a perfect square. So let's go back. How do we make 15? Well, 15 is 5 times 3, and none of those are perfect squares. The square root of 12 could be 4 times 3, and the fact that 4 is a perfect square, which means it can be simplified. So I like to use this kind of list to help me with my perfect squares. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25, 36, 49, 64, 81, and 100. So those just kind of like help me start off with my list. Obviously, the list can be longer because we can do 11 squared, 12 squared, 13 squared. But those are kind of my go-tos that help me kind of look at it. Okay, so to help us figure out if it is simplified or not, we need to look for factors of these radicals. Okay, so 27. I can make 27 by doing 1 times 27. 2 doesn't work, that's a decimal, and I could do 3 times 9. I'm checking to see, are any of these perfect squares? Well, 9 is a perfect square, so it can be simplified. So it is not yet fully simplified. Okay. All right, for the square root of 38, what makes 38? Well, 1 and 38, 2 and 19. I think that's it. None of these are perfect squares, so this is fully simplified. Okay. And then finally, we have the square root of 125. The square root of 125 is 1 times 125. 125 divided by 3, no. 125 divided by 4. 125 divided by 5 is 25. So 5 and 25. When I look at these factors, 25 is a perfect square. So it looks like we will be able to simplify this a little bit further. So that's what you first just have to ask yourself. Are there perfect squares in these radicals? Okay, so we can use the product property of square roots in our knowledge of perfect square factors to simplify radical expressions with these steps. Okay, the first thing we have to do is we have to find the largest perfect square if of the radicand. Okay, so for this one, the square root of 24, we have to ask ourselves, what is the largest perfect square that can go out of it? Okay, I'm going to write the perfect squares again, just at the top so I feel comfortable with them. So perfect square 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. We'll kind of stop right there, right? So if I look for what is the biggest square in 24, well, I know 4 is divisible by 24, so we'll split it up by doing 4 times 6. Okay? Then what you'll do is you'll rewrite the radicand as a product using the perfect square factor and the product property. Okay? Because the square root of 24 is the same thing as the square root of 4 times 6, we can also rewrite that as the square root of 4 times the square root of 6. Okay? Then what we're going to have to do is we're just going to simplify the perfect squares that we know. So we're going to take the square roots of any perfect square. So finally, we'll be like, okay, well, the square root of 4 is 2. So simplified, the square root of 24 is the same as 2 square root of 6. Okay, and the way you can check that is doing the square root symbol. So just find the square root symbol. You find the x squared button. So you do second x squared to get the little symbol, and then do 24, and I get 4.898979486. Cool. Okay, now let's check 2 square root of 6. So we're going to do 2 first, and then I'm going to do the square root symbol. So second x squared, and then 6, and it looks exactly like what's on my paper right now. And I hit enter, and I also get 4.898979486. Okay, so all we're doing right now is we're just simplifying our radicals. We're not changing it at all. We're just rewriting it a little bit simpler and easier way. Okay. So what we're going to do is we are basically just going to simplify these. Okay, so we first have the square root of 48. I need to ask myself, what is a perfect square that would go into it? So 48 right here. 36 is not divisible by 48. 25 isn't. Maybe 16. So I'm going to do 48 divided by 16, and I get 3. So I know that the square root of 48 is the same as the square root of 16 times the square root of 3, because 3 times 16 is 48. Okay. Now I know that the square root of 16 is 4. Okay. I don't know the square root of 3. You get a really weird decimal. So simplified, this is just 4 times the square root of 3. All right, the next one, the square root of 300. So I'm finding a perfect square. I think 25 goes into it, but I'm going to look for a bigger one. Looks like 100 is a perfect square. So 300 divided by 100 is 3. So this would be the same as the square root of 100. times the square root of 3. Okay, the square root of 100 is 10. Square root of 3, I have no idea. But simplified, that is 10 square root of 3. Now, let's just say maybe you saw 25 and you're like, I'm just going to go with 25. So 300 divided by 25 is 12. So you could have done the square root of 25 times the square root of 12. Okay. And when I look at the square root, I know the square root of 25 is 5. Okay. But when I look at the square root of 12, it looks like there's still another perfect square that's in there. The square root of 12 is the same as the square root of 4 times the square root of 3. And the square root of 4 is 2. I don't know the square root of 3. And the way they could also come up with 10 is just multiplying 5 and 2, which is 10, and then just keeping the square root of 3. So you don't have to use the largest perfect square, but it will make it a little bit quicker if you're trying to just do it fast. Okay. Number 6, 2 square root of 45. So I need to look right now at square root of 45 and look for the perfect square. Looks like 9 might be it. I don't think anything else is divisible by 45. So I'm going to write the 2. Okay, I know that 9 is divisible by 45, and I'm going to do 45 divided by 9, and I get 5. So again, this right here is the same as the square root of 45. And then I know that the square root of 9 is 3. So then I multiply 2 and 3, because those are like my outside numbers on the outside, and I get 6 square root of 5. Again, what you always can do is type these both in your calculator to make sure you're not really changing anything. So I can type 2 square root of 45, and I get 13.4164076. Okay, and then I can also type in 6 square root of 5, which is what I got for when I simplified it, and I get the same exact thing. So that means I know I'm right because at least I have the same answer when I type it into the calculator. Okay. Joe and Audrey believe that their expressions below are already in simplest form. Circle the student who is correct and simplify the expression of the student who is incorrect. Okay, so what I'm going to first do is I'm going to look for, perfect squares. So 153 is in the radical, and I'm going to see if I can figure out anything that can be like divided by it. So 153 is kind of hard, so I'm going to do 153, and I'm just going to divide by my perfect squares and kind of see what happens. So I'm going to divide by 4, and I get a decimal. I'm going to divide by 9, and I get 17. Okay, so I'm going to start with 17. Looking right off the bat, I know that Joe is incorrect because he is not all the way simplified. So I'm going to do the square root of 153 as the square root of 9 times the square root of 17. I'm going to bring down the 3. Okay, again, this is the same exact thing as what Joe wrote. Okay, but Joe wrote that it was fully simplified. Okay, square root of 9 is 3. So my answer is 9 square root of 17. Okay. Now with Audrey, let's just kind of see and make sure that she is also correct. So what I'm going to do is I'm basically just going to divide by some perfect squares. So I'm going to divide by 4, I get a decimal. Divide by 9, I get a decimal. Divide by 16, I get a decimal. Divide by 25, I get a decimal. And I'll divide by 36. So it does not look like that it can be any further simplified. So Audrey is actually correct. She could simplified it already. Joe had to keep going. Okay. Tamika is baking cupcakes. The square pot holder has an area of 40 square inches. Okay. Simplify an expression to represent one side length. So like the problem before, we knew that the area of the inside was 144. So it wasn't very difficult to figure out that 12 times 12 is 144. But what we have to figure out now is what number times itself or squared equals 40. Okay, so what we need to do is we basically just need to take the square root of 40, and that will tell me what number times itself. So I'm going to do square root of 40. I know that at least 4 times 10 is 40, and 10 can't be simplified, it's just 2 and 5. So the square root of 4 is 2, and then the square root of 10. Okay, now I can check myself. If I do 2 square root of 10, and if I times that by itself, times 2 square root of 10, I get 40, which means I did take the square root the right way. Okay, last one. Ulysses simplified square root of 72 and got 3 square root of 8, as shown below. Explain why his answer is not correct and give the correct simplified expression. Okay, well, just looking at this answer, The square root of 8 can be simplified because square root of 8 is 4 times 2, and 4 is a perfect square. So let's just make sure that maybe he just didn't take like the biggest perfect square. Okay, so the square root of 72, I'm going to look for the biggest perfect square because he says 9's right, and 9 times 8 is 72. But let's check maybe a different, I wrote 79. Let's check other perfect squares and see maybe something else can be taken out. So we did 9, so I'm going to do 72 divided by 16. And I get 4.5. So I'm going to do 72 divided by 25. 72 divided by 36, I get 2. So even simpler, the square root of 72 can be the square root of 36 times the square root of 2. And the square root of 36 is 6. So this is the actual fully simplified answer. Okay, what you could do is you could just simplify the square root of 8 further. The square root of 8 is 4 times 2, and the square root of 4 is 2. And then you would just bring out the 3 times 2, which is 6, and you would just rewrite the square root of 2. Okay, so today there's some Delta math. There's a couple that kind of just guide you through what we just did, just kind of help you make sure like you understood what's going on. And then there's just some straight Delta math questions. And then we'll have some time to finish and then do some more practice tomorrow.